Hello, everybody, and welcome to the Prognard. I am your host, Jacob Williams, and continuing with my Armchair General series, where I like to get into some of the mathematics of game mechanics and game situations. I wanted to talk today about diving a little bit deeper into one of my favorite games, Xia Legends of a Drift System. So, one of the more interesting title cards in this game is the title card called Gambler, where you have to successfully salvage 7 times in one turn. Alright, so what I wanted to do today is talk about the probability of successfully completing this title card. Alright, so I've got Mock Horror out here, and I'm going to be embarrassed if I remember the ship name wrong. And it's on the Space Kreller 4. And I'm on a mining spot. And let's say this title is out, okay? Now, what is the probability that I can successfully successfully salvage in one turn? All right? So let's look at the mathematics behind this. And again, and like I said in my Twilight Struggle video, I don't recommend you breaking out these probabilities in the middle of a game. All right. So first of all, what is a salvage the salvage operation on this tile? Well, we roll a d20, and on a 1 through 3 we instantly die, and a 4 through 20 we get a cyber resource. All right. So 1 through 3 we die, but 4 through 20 we live. So that's a 17 in 20 chance that we succeed. Now there's a couple ways we can do this, and I'm going to do this first the more intuitive way. And this is the way I discussed it in the Twilight Struggle video. So we have to do this 7 times, right? And think about what I'm saying here. You have to salvage 1 time, and salvage another time, and salvage another, and salvage another. And remember from the last video, anytime we multiply anytime we what's a better way of rephrasing this? Anytime we have to do things and they have to all happen together, we call that anding. And anytime we have an and, it's talking about multiplication. All right? So we have to multiply 17 times 20. 17 20ths 7 times. And one more here. Because these all have to happen in a row. Now, one thing I want to clarify here before we go any further, a lot of people, especially those people who aren't as familiar with statistics as others, this goes to like the classic coin problem, like when you say, what's the probability of flipping 5 heads, okay? People will say, well, it's always 50-50 because there's 2 sides of a coin. So some people might say, no matter what, your probability is always 17 out of 20 to complete this title. But they're right in a sense. In one instance of a salvage operation, the probability of success is 17 out of 20. But remember, we're saying something fundamentally different. We're saying, what's the probability, not knowing ahead of time, of completing it 7 times without dying, okay, which is a very different question. All right, so we have to do it 1 time, and a 2nd time, and a 3rd time, and a 4th time, and so on and so forth until we get to the 7th time that we have to do it. Okay, and we could also write this as 17 20ths to the 7th power. Okay, and then when we multiply this out, and I've got a calculator here off screen, the probability that probability of success is about 32.1%, rounding it to one place. So that's not very high, and you would expect that, right? Because even though you have a high success and it's only a 15% chance of failure, you have 7 opportunities to fail, and all it takes is one time to fail. Let's actually look at a different way to do this, because this is going to come up in a future video that I'm going to do. Let's look at this doing this through using what they call binomial theorem or a Bernoulli trial. Okay, so there's a formula out there that goes X choose Y, and choose is a mathematical operation. You can Google that if you're not familiar with it. And then you multiply it by the probability of P. And first of all, X is the total number of experiments. In statistics, when we talk about experiments, we're talking about you just do whatever it is and see what the result is. So flipping a coin can be a probability experiment. Doing a salvage operation here is a statistical experiment. Okay, so X is the number of experiments, and then Y is the number of successes. And you can only do a binomial theorem or a Bernoulli trial if all you care about is success or failure. Okay, that's kind of one of the conditions for using this. So anyway, X choose Y, and then P is the probability of success. All right, and we're going to raise that to the y-th power. All right, and then we multiply this by 1 minus P, or the probability of failure, to the x minus y power. Okay, so now applying it to our situation, we're going to do 7 experiments, and we have to be successful all 7 times. Okay, and then we've already discussed the probability of success is 17 out of 20, and that's to the 7th power. And then we're going to do the probability of failure, which is 3/20, because remember, these two have to add up to be 1 according to classic probability. And then we're going to raise this to the x minus y, but 7 minus 7 is 0. And then something really cute happens. Anything choose itself is 1. Anything to the 0th power is also 1. So now we're right back to 1 times 17/20 times 1, which is the same as 17/20 to the 7th power, which we already discussed is approximately 32.1% probability that will happen. Now, this is if you haven't even attempted the title and you're just trying to think in your head, is it worth it? Okay? But let's say you needed to get a couple of cybers and you've already completed, let's say 2. You wanted 2 cubes because you wanted a quick victory point, and you're thinking, oh, well, I've already got 2 down. What's the probability of getting to the 7, which is 5 more trials in this case? Well, that's pretty easy to calculate because you've already done it twice, so you don't have to account for those experiments. So you can just do 17/20 to the 5th power, which is, one second, is about 44.4%. All right, so the further you go along in the experiment, the closer or the higher your chances of success. But remember, if let's say you've done 6 successfully and you want to know what's the probability of getting that last one, and now you're back to that situation I talked about at the beginning, you only need 1, so that's just 17/20 to the 1st power which is actually, it's exactly 85%. All right. So I hope you found this useful. In my next Armchair General, I'll be using binomial theorem to discuss the probabilities of major jihads in the game Labyrinth, the War on Terror. Thanks a lot, and we'll see you next time.